Good morning, everyone. So yesterday we discussed about DR BDR election. So first question, why DR BDR? Yes, guys. Yes. Why we require DR BDR election?
It avoids mesh.
Avoids mesh. Okay, then is used to reduce the flood of LSA. Good. In a multi-axis network. Is at this point. So DR BDR election happens in BMA networks. So we'll talk about this when we talk about network types. So BMA and NBMA networks. So what is the election criteria in order to elect a DR and a BDR? What is the by default priority of OSPF? One. Very good. So highest OSPF priority. If same, then highest route rate. Good. So first, DR will be BDR will be elected, and then the DR will be elected. Now, so yesterday we have seen this topology. Let us consider we have 4 routers. So router ID of R1 will be 1.1.1.1. Router ID of R2 will be 2.2.2.2. Router ID of R4 will be 4.4.4.4. And router ID of R3 will be 3.3.3. And let us keep the OSPF priority as 1 by default on all the routers. Now, who will become the BDR and the DR? So R3 will become the BDR and R4 will become the DR. Now, your task for today. So now I want to make R1 as the DR and R2 as the BDR. So how to do this? Yes. By changing router ID. Okay. Highest router ID. Any other answer?
Priority.
Priority. You can change the OSPF priority. So please do this lab today. So how to change the OSPF priority? I will let you know. So you need to go to interface name. This is the command. Please make a note of this command. IP OSPF priority. And you can assign the priority depending on the requirement. So make R1 as the highest priority and R2 as the second highest priority. So this is your task. You need to finish it by today.
And Chitan, one thing more, like which router comes first, right? That will become the DR, or when
No. Election will take place. Election will happen. So after election only, they will elect the DR and the BDR. So if you want to, do a re-election, let us consider I went and changed the priority of the DR as 150 and BDR as 100. Now, till you clear the process, clear IP, OSPF process, they will not reinitiate the election. So you need to clear the process and then only R1 will be elected as DR and R2 will be elected as the BDR.
No, like you said, when all routers came up, then only the election happened. Then DR, BDR happened.
Yes.
Right. But in a network, if we some a topology will assume there is only 2 routers in the same subnet, then 3 routers, not 4 or 5. then it will not happen.
No, I didn't get you, Darshan.
Like in
Yes,
a topology, in the
okay.
multi-access network, we have 5 routers, right?
5 routers, okay.
Then if what will happen if 3 routers came up with the lowest one, R1, R2, R3, not R4 or R5.
Okay.
Then election will not happen.
Election will happen. So if you connect R4 and R5, then the same DR and BDR will. Let us consider we have 3 routers. So he will become the DR and he will become the BDR. Once you connect R4 and R5, again you need to clear the IP.
Clear. Okay. Then
otherwise, they will not re-elect themselves. Here R3 will remain as the DR and R2 will remain as the BDR.
So overall is when everything is powered up and configured, then we have to clear it up.
You are right. Yes. I hope this part is clear. Task is clear. Now one more task. What is the second task? Task 1 is you need to make R1 as the DR and R2 as the BDR. What is the task 2? So how to disable a particular router from participating in DR BDR election. Any idea? If you don't have idea, please Google it. You'll get the answer. Particular router. Router. Yes, tell me.
We can make the priority as 0.
Very good. So from not disabling, from participating in DR BDR election. So these are the 2 tasks. Please finish it by today. Participating in DR BDR election. So these are the 2 tasks. First task is you have to make R1 as the DR and R2 as the BDR. Don't change the router ID. That router ID remains the same. Please play with the priority. So the command to change the priority is interface name, IPOS priority, and then the priority control. Clear? I hope this is about DR BDR election. Please complete this task and submit it by today. Done? Done? Okay. So now we'll see how to configure OSPF between different areas. OSPF multi-area. So let us consider we have R1 and R2. We have R3 and we have R. So these 2 are in area 0. These 2 are in area 1. And these 2 are in area 2. So let us consider we have a loopback /32 /32. So the network will be 192.168.x.x/24. This is 12.0/24.1.2, 13.0/24.1.3. This is 24.0/24. This is .2 and this is .4. So now, so one more point, key point to remember. So the router connect into two different areas. We call that router as ABR. What remember ABR? ABR stands for area border router. So when R1 is the ABR and R2 is the ABR. So it is a router that is connected with multiple areas.
Got a recommendation from my math teacher.
Area border router. Done? Done? Okay. Let's say how to configure this. Done, right? After this, one more task. Small task. So let us consider 4 routers. So we have R1, we have R2, R3, and R4. So these two are in area 0. The IP address will be 192.168.12.0/24. Between R1 and R2, so R1 and R3 are in area 1. So R2 and R4 are in area 2. So the IP address will be 192.168.13.0/24 between R1 and R3. So between R2 and R4, it will be 192.168.24.0. We provide the IP addresses on R1. Interface is 0.0. What is the IP address? 12.1/20. No shit. Interface is 0.1. IP address will be 192.168.13.1/20. On R2, so interface Z0/0 will be 192.168.12.2 and Z0/1 will be 24.2. So on R3, so Z0/0 will be 192.168.13.3 and we'll have a loop back here. So IP address will be 3.3.3.3/30. On R4 also we have a loop back 4.4.4.4. So now on R4, interface is 0/0. So the IP address will be 192.168. Very good. 24.4 and we have a loop back 4.4.4.4. Just copy paste. Then we'll enable OSP. Okay. R1 is done. R2. R3. And R4. So how to enable OSPF? Okay. Then go to OSPF. Process ID then. Okay. Router ID. Then network, IP, wildcard mask, area, and the This is one way. So you can enable one more way under the interface. So you can go to interface name. The command is IP OSPF process ID, area and the area ID. This is the command. First way to enable OSPF. This is second. No? Okay. No, you need to go under the OSPF, then only change. You can't change the router ID under the interface. You just enable OSPF. Yeah. So let's go to R1 and enable OSPF. So router OSPF 1. So router ID will be 1.1.1.1. So network. So you need to advertise directly connected networks. So we have 192.168.12.0, 255 and area 0. Enter. Network 192.168.13.0, 255 and area 1. This is the configuration on R1. OSPF 1 router ID. So 12.0 will be in area 0 and 13.0 will be in area 1. So how to check which are all the interfaces are under the OSPF? Show IP OSPF interface brief. So Z0 bar 0 is in area 0 and Z0 bar 1 is in area 1. Very good command for troubleshooting. So go to R2 and enable OSPF. Router OSPF 1. Router ID 2.2.2.2, and this must be unique, otherwise your OSPF adjacency will not work. We'll talk about the neighborship criteria. So network 192.168.12.0, area 0. Network 192.168.24.0, wildcard mask and area 2. Yeah? Area 2. So run pipe section 4. No problem. Just go and enable under R3 and R4. So on R3 and R4, we'll enable OSPF under the interface. How to do that? Go to the interface 0 bar 0. The command is IP OSPF 1. Process ID and area and the area ID. Enter. Go to the interface loopback 0 and enable OSPF. Very simple. Show IP OSPF interface brief. So you have enabled OSPF 1, loopback 0 and Z0 bar 0. This part is clear. So now go to R4 and enable OSPF. So interface Z0 bar 0, IP OSPF 1, area 2, interface loopback 0. Show IP OSPF interface. Loopback 0 is enabled under area 2 and Z0 bar 0 is enabled under area 2. Clear? Now. So now before checking the output. So now, if we talk about R3. So what will be the routing table of R3? So how many directly connected networks? We have 2 directly connected networks. 3.3.3.3 slash 32, and we have 192.168.13.0 slash 24. 0 bar 0. This is loopback 0. Now, tell me, what about 12.0, 24.0, and 4.4.4.4? What type of routes these are? So these type of routes, we call it as inter-area routes, OIA, because these networks are coming from different area. We call it as OIA, inter-area routes. How many OIA routes? On R3, we have 3 inter-area routes. We have 12.0, 24.0, and 4.4.4. These type of routes, we call it as inter-area routes. Clear? Now, go and check. So go to R3 and check the neighborship. Show IP, neighbor. So we have one neighborship with 1.1.1.1. So on R1, we'll be having 2 neighborships. Show IP, OSPF, neighbor. 2.2.2.2 and 3.3.3. 2 neighborships. 7 on R2. We'll be having 2 neighborships, one with 1.1.1.1, one with 4.4.4. Clear? Now, so if you check the routing table of R3, show IP route OSP. So how many OIA routes? We have 3 OIA routes. What is the designation of IA? It is inter area, not intra area within the area. It is inter area route. Can you see here? What do we mean inter area? It is coming from different area. It is not originated on area 1. It is originated from area 0. And it is originated from area 2, different areas. That's why we call it as inter area. If we talk about the AD value, again the AD value is the same. So for intra area and for inter area, the AD value is same. That is 110. So even if you go and check on R4, so IP route, are we able to reach? Clear? Anybody has any doubts? Yes, online guys, clear? Clear? Not clear? Okay. So now we'll move on to LSA types. Anybody has any idea how many LSA types we have?
11.
How many?
11.
11. Are you talking about OSP version 3 or version 2?
Version 2.
Version 2 is 7. We have 7 LSA types. So you are
But
talking about OSP.
further, we have many which depends upon MPLS and all.
What MPLS? Tell me what are the LSA types? Tell me the rest 4. So I will tell you 7. You tell me the rest 4, okay? Because in OSP version 2, I know we have 7.
Rest 4 depends upon the segment routing and ISIS MPLS related stuff.
ISIS we are not studying, right?
No.
No.
I'm talking about the MPLS part.
MPLS part is there, MOSPF or LSA. But that LSA is not at all used in what is say OSPF. That you can't see even in the routers as well. Clear? Very good. So we have LSA type 1. Very important for interviews. Type 1 LSA. We call it as router LSA. So you need to know two things about this LSA types. Who is the originator and what is the flooding scope? Who will originate this LSA and till where this LSA can flood? So if we talk about type 1 LSA, every router will originate this LSA. For scope within the area. So we have type 2 LSA.
Network LSA.
Network LSA. Good. So who is the originator? Who will originate this LSA? DR is the originator. What is the flooding scope? Within the area. Done. Next LSA is type 3 LSA. We call it as summary LSA. Who is the originator? ABR is the originator. Flooding scope in between areas. We have type 4 LSA. ASBR, summary LSA. Who is the originator? Again, ABR. So the use of this type 4 LSA is, it is used to calculate the cost from the ABR towards the ASBR. So ASBR stands for Autonomous System Boundary Route. We'll talk about that.
What is the threading scope of type 4?
Again, in between multiple areas. Do not flood after the ASBR.
But they don't. Okay.
Yes.
Sir, one more question. Type 1, the scope is within the area,
Yes.
right?
Yes.
So when it comes to, and every router will generate that.
Yes.
Then ABR,
It will convert it to type 3.
okay.
Yeah.
Okay.
Yeah.
Why we need to have type 4 LSA? I mean, I'm not very clear on it.
I told you, no? Know the
It is used
cost.
to calculate.
Yes.
It is used to calculate the cost from the ABR towards the ASBR.
ASBR.
Why we need to have that cost?
Because you need to know, right? How far is your ASBR?
Okay.
So I'll talk about this LSA, don't worry.
Yeah.
We'll do a lab. We'll do a lab on this. We'll talk about this LSA. Clear?
Yeah.
Okay. Type 5 LSA. You call it as external LSA. Who is the originator? ASBR. Flooding scope. So we have type 6. We don't use this LSA. We call it as MOSPF. And we don't have this LSA type. We have one more LSA, that is type 7. This we call it as NSSA, external LSA. So this LSA type we'll understand when we do area types. This will come into the picture when we have NSSA areas. Again, the originator.
Sir, type C multicast LSA.
Yes.
Okay.
Multicast OSPF.
Okay.
What is scope? So this type 7 LSA will come into a special case when we use NSSA. So we'll talk about this type 7 when we discuss about NSSA LSA. Not so severe.
Sir, why not use type C LSA?
Yes.
Why not use type 6 LSA multicast?
I will tell you in the lab, because this was used for carry the BGP attributes that we don't use nowadays.
Okay.
So you can just ignore this. There is a command, even you need to search in the Google. So this you can't even see in the OSPF database. So we have only 6, that is 5 and 4. This is used to carry the BGP attributes. So this is not supported in your Cisco.
Okay.
Yeah. Okay, now done. So before doing the lab, you need to know about what? So what do you mean by redistribution? Any idea? Yes, online guys, any idea about redistribution?
Moving routes from one routing protocol to another routing protocol.
Okay. So again, it is a process. Of exchanging routes between two different routing protocols. Or between two different ASNs. Or when you use redistribute connected command. ERGRP ASNs. ERGRP ASNs. Yep. Okay. So now we'll do a lab. We have R1. So we have R2. We have R3. And we have R4. So these two are in area 0. These two are in area 1. And these two are in ERGRP ASN 1. So who is the ABR and who is the ASBR? So one more thing. ASBR stands for Autonomous System Boundary Router. Is mute. So it is a router. Connected between different autonomous systems. So who is the ABR here? What is the ABR? Why? Two different areas. What about ASBR? R3. Very good. Why? Two different. This is OSPF. This is running. Yeah. Now, so what R1 will generate? What type of LSA? So every router will generate type 1 LSA. That is your router LSA. What is the flooding scope of this LSA? Within the area. So till R2, this LSA can reach, right? So now what about R2? So now how R3 will be able to know about, let us consider about this net. So the ABR's responsibility is to convert this type 1 LSA into type 3 LSA. Who will generate this LSA? ABR. What is the flooding scope? In between two different areas. Now, R3, till R3 it has reached. Now what about R4? Now it will generate a type 5 LSA. Who will generate this? ASBR. Flooding scope between two different autonomous systems. Okay. So one more question I wanted to ask you just. So let us consider, do we have a DR BDR election here? So I'm talking about R1, R2, and R3. What do you think? No, I'm talking about R1, R2, and R3. So how many DRs and how many BDRs? One BDR. Two DRs, one BDR. Okay. Any other answer? DR depends on how many area is there. Do you think DR is elected based on the area? No, no, Manoj. DR is not elected based on the area. So DR and BDR is elected per segment, depending on the network type. If you talk about the network type, by default network type is BMA. So in BMA, we have DR, BDR election. So per network segment, it will elect a DR and it will elect a BDR. Means how many DR and BDR here? So we have two DR here and two BDRs here. So per network segment, please make a note. If anybody asks in the interview. So depending on the network type, if it is BMA, then every network segment will have a DR and a BDR.
That means between R1 and R2,
Yes,
there is a DR and
Very
BDR,
good.
and between R2
Yes.
and R3, there is a DR and BDR.
Very good. So R2 will be the DR, R1 will be the BDR. So here in R2 and R3, R3 will be the DR and R2 will be the BDR per network segment. Here, BMA. It will be a BMA by default. I'll show you in that. It will be by default network type is BMA. If it is point to point, then we don't have any DR BDR. We'll talk about the network types. BMA stands for broadcast multi-access. And what is the hello and hold of BMA? Hold is 10. What about hello? What about hello and dead timer? It is 10 and 40. Clear? Done? So note. So every network segment will have a DR and a BDR. Very important point from the interview perspective. No? Okay. We'll see this now. NBM also. You rarely see that network. Same relay. We'll take 4 routers. Area 0. Area 1. ASN 1. So the IP address between R1 and R2 will be 9168.0.0/24. So R1 has a loop back. /32. R4 also has a loop back. 4.4.4.4. So the IP address between R2 and R3 will be 23.0/24. The IP address between R3 and R4 will be 34.0. So the router IDs will be where X is the router number. Yeah. For R1 it will be 1.1.1.1. For R2 it is 2.2.2.2. R3 it is 3.3.3.3. R4 it is 4.4. Okay. So let's create the IP addresses on the notepad. So in R1 it will be 12.1. And we have a loopback. /32. No, on R1. So on R2, G0 bar 0 will be 192.168.12.2 and G0 bar 1 will be 23.2. Yeah. So on R3, G0 bar 0 will be 23.3 and G0 bar 1 will be sorry. G0 bar 1 will be 192.168.34. slash. So on R4, so Z0 bar 0 will be 34.4 and loopback 0 we have 4.4. Just copy paste. Should I enable OSPF here only? Is it fine? Or should I show it on the router? Is it fine to enable here? Router, OSPF, network. For that, router ID 1.1.1.1. The network 92.168.12.0. Wildcard mask area 0. Network 1.1.1.1. Wildcard mask and area 0. So on R2, so router ID will be 2.2.2.2. So network 12.0 is in. Yeah, sure, going. Where is it? Okay. So network 192.168.12.0, area 0, and network 192.168.23.0, area 1. No? So on R3, so router OSPF 1, so 3.3.3.3, and we have 23.0, area 1. Then what about 34.0, area? So we need to enable under EIGR. Router EIGRP 1. So EIGRP router ID 3.3.3.3. Network 192.168.34.0. No auto summary. Yeah. Now go to R4 and enable EIGRP. So router EIGRP 1. EIGRP router ID network 192.168.34.0 network 4.4. So now just copy paste. Few moments. So on R1. So on R2. On R3. On R4. Yeah. So now before checking the output. So router ID. What is the router ID here? So if we talk about R1, so what type of LSA it will originate? Type 1, only type 1 LSA it will originate, or any other LSA? Only type 1? Type 1. So what about R2? R2 will originate type 1 LSA, type 2 because he's a DR, and type 3 as well because he's a ABR. He's not the DR. Per segment, I told. Per segment means here there will be one DR BDR election, and this segment will have another DR BDR election per segment. So only DR will originate type 2, not BDR. So now, if we talk about router 3. So router 3 will originate type 1, type 2, type 3, not type 4. Type 4 is originated by ABR. Type 3 and not type 3. Why type 3? Is the ASBR. Type 1, type 2, and type 5. ASBR. He is the ABR and he is the ASBR. Clear? Now, clear? Now, we'll go and check the database. So before checking that, now, by default, the OSP of network type is broadcast multi-access. Just see that first. What is the by default network type? Can you see? It's broadcast. Clear? What is the hello and hold for broadcast? It is 10 and 40. Can you see here? Per network segment, it will elect a DR. Who is the DR for this network segment? It is 2.2.2.2. What is the by default priority? Priority is 1. I hope everything is fine. Now, so if you go to R2, you will see one DR and one BDR. Show IP OSPF interface name. G0/0 will be the BDR. Which is the BDR? 1.1.1.1. So check interface G0/1. Again, this time is the BDR. Who's the designated router? Per network segment, it will elect the DR and BDR. I hope this part is clear now. So go to R1 and check the database. The command to check the database is show IP OSPF database. This is where you check LSA types. So all the LSAs will be present inside the database. We call this database as LSDB, link state database, where your all the LSAs are stored here. One minute, please. We'll come back. Show IP OSPF database. Enter. Now check. So now, if we talk about type 1 LSA, this is a type 1 LSA. Who will originate? Every router will originate within the area. What is the flooding scope? Can you see on R1? We can see R1, that is 1.1.1.1 is generating type 1 LSA, and 2.2.2 is generating LSA. And who is advertising router? 1.1, that is R1 and R2. So both will originate the LSA. And what is the flooding scope? Within the area. So this is type 2 LSA. Who is the originator? 2.2.2. That is the DR. What is the flooding scope? Within the area. And who will originate this LSA? Type 3 LSA. Who will originate? ABR. ABR. Who is the ABR? 2.2.2 is the ABR. Clear? So now go to R2. Show IP OSPF. Here we'll have information about two areas, area 0 and area 1. For area 0, both the routers will originate type 1. Type 2 will be originated by the DR. What about type 3? ABR. This is for area 0. So if we talk about area 1, area 1 also will originate type 1 and type 2 LSAs. This time, who is the advertising router here? For type 2, who is the DR? 3.3.3 is the DR. Now, what about this LSA? Who is originating again? ABR. Clear? Go and check on R3. R3 will have your ASBR information. Show IP OSPF database. We didn't redistribute it. So no redistribution, no type file. Okay, before that. So for area 1, same here, type 1, type 2 is originated by the DR and type 3 is originated by the ABR. Why we don't have a type file LSA? We didn't do redistribution. Okay. Just if you go and check on R3, R3 will have show IP route OSPF. So we have two OIR routes. One is 1.1.1.1 and 12.0. Why OIA? Because it is coming from different area. Clear? Now, why I'm not unable to see 4.4.4.4? No, correct. Redistribution issue. But why I'm unable to see? Different. So now go to R3. Check show IP route OSPF and show IP route EIGR. You can see 4.4.4. Clear? Now, so where into redistribute? On R3. Why on R3? ASBR is for OSPF. Why redistribute on R3? Because it is connecting to two different routing protocols. Okay, now go to router EIGRP 1. Now, what you need to redistribute? You need to redistribute OSPF routes into EIGRP. So you need to do mutual redistribution. Means EIGRP routes I need to put into OSPF and OSPF routes I need to put into EIGRP. So redistribute OSPF. And you need to mention the process ID here. 1 and then the metric type. So you need to mention the metrics, that is bandwidth, delay, load, reliability, and MTU. Because we are redistributing EIGR. So we'll just use 1. Always. You want a proper output, then you need to go to show interface name, then there will be bandwidth delay. You can just copy paste there. So in the exam, you'll get bandwidth, delay, load, reliability, and MTU as 1111. You can just substitute this. Enter. Now go to OSPF 1. Redistribute EIGRP 1 subnets. Why we use subnets keyword? Because by default, OSPF redistributes only class 1. Class 1, if you use a subnet keyword, it will redistribute classless network size. Enter. Now, so now, if you go and check on R1, what will be the route type? It will be OE2. Show IP route OSPF. Can you see the OE2 route here? External route. This route we call it as external. Again, the AD value is the same. That is 110. OE2. So O stands for intra-area, OIA stands for inter-area, and OE2 stands for external area route. AD value is again 110. Now, if you go and check, show IP OSPF database. Now we see. Now check. So we had type 1 LSA within the area. Type 2 LSA, DR will originate. Type 3 LSA, ABR will originate. Can you see what is the type for LSA who is originating? Again, the ABR. That is 2.2.2. Now, type 5 LSA. Who is the originator here? ASBR. That is 3.3.3.3. Who is the ASBR here? R3 is the ASBR and R2 is the ABR. Yeah. So type 7 LSA, you will not see here. Even type 6 LSA you will not at all see in the Cisco routers. That's why we don't consider type 6 LSA. And type 7 LSA, you will see it in the special case like NSSA. We'll see that, discuss about NSSA area type. Clear? So any doubts? Till here, you can ask.
Sorry, you mentioned there is another OSPF version.
Version 3, that is for IPv6.
IPv6.
So IP route, EIR. What is this route called? External route. What is the AD value? 170. You have reachability? Yes. Tell me what was the route? Somebody asked me that. What route was that?
No, I was just curious.
Curious. Okay.
In that year, how many?
OSPF version 3.
Okay. And then
That we'll discuss in what is it? IPv6. So in advanced classes. Clear? Now. So let me finish off another topic as well. That is network types. OSPF network types. So if we talk about OSPF network types, we have 5 network types. We have BMA, we have NBMA, we have point-to-point, we have point-to multi-point broadcast, and point-to multi-point non-broadcast. So just do the theory part today. So tomorrow we'll start with the lab. You need to remember this whole chart. So where all DR, BDR election. What is that OSPF timers? And where all static and bar dynamic neighborship. In some network type, you need to use static neighbor command. In some network types, they will dynamically form the OSPF neighborship. So BMA stands for broadcast multi-access. So NBMA stands for non-broadcast multi-access. I'll just put the arrow, please, non-broadcast multi-access. P2P stands for point-to-point. I'll write it here. And don't say I'm not written. So non-broadcast multi-access. So P2P stands for point to point, point to point, point to multi-point broadcast, and point to multi-point non-broadcast. So now, if you talk about the DR BDR election, so in BMA we have DR BDR election, and in NBMA we have DR BDR election. Point to point, we don't have DR BDR. Point to multi-point broadcast, no DR BDR, and point to multi-point non-broadcast, we don't have DR BDR election. So if we talk about the hello and dead timers. So if we talk about BMA, it is 10 and 40. So if we talk about NBMA, it is 30 and 120. That's why OSPF timers depends on the network types. Point to point, we have again 10 and 40. So these things will prove tomorrow. So hello and dead. Again, that is 30, 120. So hello dead, 30 and 120. So if we talk about BMA, there is a dynamic neighborship. So in NBMA network, you need to use static neighbor command in order to form adjacency. So in point to point again, we have a dynamic neighborship. Point to multi-point broadcast, we have dynamic. And point to multi-point non-broadcast, we have static neighbor command. So you need to enable neighbor command under the OSPF in order to form adjacency. So these are the points, few points you need to remember about OSPF. Even we have few more differences like RFC standards, Cisco proprietary, few are Cisco, few are RFC. Please research on that. Which are Cisco, which are RFC standard. So very important for interviews, please remember these points. So anybody has any doubts, guys? Till here you can ask me. I'm done for the day. So we'll continue tomorrow. So these things will prove tomorrow. Then we'll start with area types. So day after tomorrow, your OSPF is completed. So we have a few more topics. Anybody has any doubts? No doubts? Okay, guys. So then we'll end up. We'll continue tomorrow. Have a great day, guys. Bye.